Assalamualaikum warahmatullahi ta'ala wabarakatuh, and a very good day to all of you. Today we would like to proceed with the properties of Laplace transform. Previously, we have introduced to you the transformation using Laplace, but for only single functions. Okay, the single function has been summarized in the table of the Laplace transform. However, for this video, we would like to introduce to you on the properties of Laplace transform. The first property is a linearity property. The linearity property is as in theorem 3.3.1. Okay, if you have to transform one function f1 and f2 where it exists, if alpha and beta and constant, then you will have this one. Basically, it is the combinations, but you can set or you can find it separately. Alright, let's go to the exercise. Find the Laplace transform of the following function. Okay, you can see that we have never seen this type of function previously using the table. But using the linearity property, we can expand this function first. So what you can expand is, okay, you have 2t minus 5 and 2t minus 5 over here. So you will end up getting these three terms. So these three terms, you can separate it. Okay, and then you can have the transformation of the t squared, and then the transformation of t, and then finally the transformation on a constant. So by looking at the table, so you will see that you will have this particular answer. Okay, is only the direct transformation, which is you can find it in a table of the Laplace. Okay, let's go to the second question. Okay, so the second question here, we have directly showed to you x combined between two functions. Okay, 4 exponent 2t minus 5 cos 2t. So we have this one, and then we have another one. This is number 2. So you can see that we can transform it separately. So by looking at this one and this one, you can find it, the answer direct from the table. So this is the answer. Remember previously, if we have the cos over here, so the numerator here is s, and then we have over here is plus. Alright, for the exponent, we need to have a. What is your a? A is 2 over here, so it should be s minus a, means that s minus 2. So this is the answer. Now let's create our own question. Okay, for example, if you have one question to transform it, so you have, for example, ft. Okay, let me give you 2t plus t squared power of 2 minus exponent 3t plus cos 2t, for example. So look at here. Okay, look at here. You can directly get the answer for this one and also for this one, but not for this one, because this equation need to be expanded first. So how to expand this one? So you will have 4t squared, and then you will have 4t cubed, and then you will have t power of 4, and then you will have negative exponent 3t plus cos 2t. So now, according to this one, you can find it separately by taking the Laplace for function t square, and then you have 4 over here for function of t cube, and then you will have Laplace for function of t4, and then minus over here Laplace of the function of exponent 3t, and then you will need to Laplace the function of cos 2t. Okay, by referring to the table, okay, which table that you need to refer here? So this table can be found in a formula books, and in your assessment letter we will given to you. So for the first one, look at it's only have t power of 2, so the answer here is, so 4 is a constant, so you will have 2 factorial over s 2 plus 1, which is 3. And then what about this one? 4 is a constant, so you will have 3 factorial over s power of 4. And then for the third one is 4 factorial with s power of 5. And then look at here. So in this one, you need to be careful because it involves exponent. Look at, you have exponent 3t. Exponent 3t over here, look at here. Okay, so the answer is must be 1 over s minus a. Your a now is 3. And then look at, you want to find the answer for the Laplace of the cos hyperbolic. So look at the table cos hyperbolic over here. You need to find your a. So your a now, okay, what is your a? So your a now is 2. Okay, look at, your a is 2. So you will have s over s squared minus a squared. Remember, because it's cos, so it should be s over here. Due to hyperbolic, you need to have minus over here. So this is your answer. You may make it simplification by finding this value. You can find by your own. So I hope you understand further properties of a Laplace transform using the linearity property. The linearity property means that it have the combination of the function, but you can solve it separately. Okay?